here is something that should genuinely unsettle you. Right now, at this moment, while you sit reading this in what feels like perfect stillness, your body is being carried eastward at somewhere between 0 and 1,674 kilometers per hour, depending on your latitude. The ground beneath you is rotating. The building around you is rotating. The air pressing against your skin is rotating. Everything in your immediate environment is moving at a speed that would, if you could somehow step outside the system and observe it from space, look like the smooth, coordinated, high-velocity sweep of a planet turning on its axis. And you feel nothing. Not a vibration, not a whisper of wind, not the faintest sensation of motion, just the ordinary stillness of a Tuesday afternoon. But here is the thing. That rotation, the one you cannot feel, does not begin with the Earth and does not end with it. It goes up and it goes down. It goes up through every scale in the universe, the moon orbiting the Earth orbiting the sun sweeping through the Milky Way at 230 kilometers per second. The Milky Way itself rotating over time scales of hundreds of millions of years. Whole galaxy clusters with their constituent galaxies orbiting each other in slow gravitational waltzes that have been going on since before the Earth existed. Every structure at every scale turning. And it goes down. It goes all the way down to the smallest things physics can describe. To the electrons inside the atoms that make up your body. To the quarks inside the protons inside the nuclei of those atoms. At the quantum level, every fundamental particle in the universe carries an intrinsic angular momentum, a spin that is a fixed, immutable property of what it is. Not something it acquired, not something it could ever lose. A permanent, built-in rotation that the laws of physics baked into the definition of matter itself. Everything spins, from the largest structures in the observable universe to the smallest things physics can currently name. Rotation is not something that happens in the universe. It appears to be something the universe is made of. And then there is the number that should stop you cold. Add it all up. Every galaxy, every star, every orbiting planet, every spinning particle. Take the full accounting of all that angular momentum across 2 trillion galaxies. Do the vector sum. All the spins pointing in all their different directions. Every clockwise motion against every counterclockwise motion. Every orbital sweep to the left balanced against every orbital sweep to the right. The answer, to within our best measurement capability, is 0. Every piece spinning, the whole perfectly still. That is either the most extraordinary coincidence in the history of physics, or it is something far more profound, a constraint baked into the initial conditions of reality itself, for reasons that current physics cannot explain, but which may have everything to do with why time flows the way it does, why causality works the way it does, and why the universe is inhabitable by anything at all. This is the story of why everything spins. Where rotation comes from, how it propagates through every scale in nature, what it builds when it gets there, and why the number at the bottom of the ledger is the most important 0 in science. The rotation you cannot feel. Nothing around you is still. This is worth sitting with before moving on, because your body has spent its entire life constructing the illusion that the environment is fundamentally at rest, and that motion is the exception that needs to be explained. The floor feels fixed, the walls feel fixed, the air in the room feels, unless a window is open, like it is doing nothing whatsoever. All of this is an artifact of your reference frame. When a system rotates at a steady rate and you are embedded within it, your nervous system has no way to register the motion. You are not wired to detect constant velocity. You are wired to detect changes in velocity. The moment something accelerates sharply, a car braking, a lift stopping, you feel it immediately. But smooth, continuous rotation at a fixed angular rate. The brain registers it as stillness. It is not a failure of perception. It is an accurate description of what it feels like to be inside a consistently rotating system. Inside that system, the physics is genuinely identical to being at rest. Only an external reference point makes the rotation visible. The Earth rotates once every 23 hours, 56 minutes, and 4 seconds. At the equator, the surface moves at roughly 1,674 kilometers per hour, faster than the cruising speed of almost every military aircraft ever built. At the latitude of London, Paris, or New York, the speed is lower but still several hundred kilometers per hour. The atmosphere above you is doing the same thing, dragged along by friction and gravity, co-rotating with the surface in a way that keeps the whole layered envelope of air moving together as one coherent structure. The oceans are doing the same. Every layer of this planet, from its iron core to its outermost atmosphere, is rotating as a coupled system. The one place this coupling breaks down slightly, the one place you can actually see the Earth's rotation expressed as a direct physical effect, is in large-scale weather systems. When air masses try to move in straight lines across a rotating surface, the rotation deflects them. In the northern hemisphere, moving air is deflected to the right. In the southern hemisphere, to the left. This is the Coriolis effect. Hurricanes and typhoons spin counterclockwise in the north and clockwise in the south, not because of any inherent preference in the fluid dynamics of air, but because the ground beneath them is turning. Every time a satellite photograph shows the graceful spiral arms of a tropical cyclone, you are looking at the Earth's rotation writing its name in the clouds. But this is only the beginning, because the rotation does not stop at the scale of planets and weather systems. It goes deeper, much deeper. The spin at the bottom of everything. Inside every hydrogen atom in your body, in the water in your cells, in the proteins folded in your tissues, in the DNA coiled in every nucleus. There is a phenomenon that has been broadcasting evidence of quantum rotation across the entire observable universe since before the Earth existed. The hydrogen atom is the simplest atomic structure. One electron orbiting one proton. Both particles carry their own intrinsic quantum spin. Most of the time, the electron and proton have their spins oriented in opposite directions, because that is the lower energy configuration. Occasionally, the electron flips to align with the proton, a slightly higher energy state, and then flips back. When it flips back down, it releases a single photon at an extraordinarily precise frequency, 1,420,405,751 Hz. 1.42 gigahertz. Not approximately, not roughly, exactly. This frequency is so stable, so consistent, and so universal that radio astronomers use it as a standard beacon to map hydrogen gas across the entire Milky Way and beyond. Point a radio telescope at any region of the cosmos where hydrogen exists, which is almost everywhere, since hydrogen constitutes roughly 75% of all ordinary matter. and you will find this frequency. The universe is broadcasting it from every direction simultaneously. Every hydrogen atom that has ever undergone this transition has been transmitting a signature of quantum spin into the void. This is not rotation in the classical sense. It is not a tiny sphere spinning on an axis. The electron is a point particle. It has no known spatial extent, no surface, no radius to sweep around. Quantum spin is something more fundamental than classical rotation, and we will return to what exactly it is. But it behaves like angular momentum. It is quantized, conserved, and intrinsic to the particle in the same absolute way that mass and electric charge are intrinsic to it. The hydrogen in your body is not just participating in quantum spin incidentally, the way a passenger participates in the motion of a train. The spin is part of what hydrogen atoms are. It is built into their definition. Remove it, and you no longer have hydrogen. You no longer have chemistry. You no longer have anything resembling the material world. So here is where we stand after the first two parts of this story. Your body is rotating eastward at hundreds of kilometers per hour on the surface of a planet. That planet is orbiting a star at 30 kilometers per second. That star is orbiting the center of a galaxy at 230 kilometers per second. And at the bottom of all of this, inside the atoms that compose every single thing you can see or touch, there is a layer of intrinsic quantum spin that never stops, never winds down, and requires no energy whatsoever to maintain. Motion is not something that happens in the universe. Rotation is the ground state of matter embedded in gravitational systems. The stillness you feel around you is a local illusion. The universe, from the quantum to the galactic, does not do still. The law that holds everything together. Beneath all of this rotation, at every scale, there is a single law running without exception and without any mechanism to enforce it. Because laws of this kind do not need enforcement. They are consequences of something deeper. Angular momentum is conserved. That sentence sounds simple. Its implications are not. What conservation of angular momentum means, worked out to its full consequence, is this. Any spinning or orbiting system that is not acted upon by an external twisting force will continue spinning or orbiting indefinitely, not slowing gradually, not eventually winding down. Indefinitely. Remove all friction, all drag, all gravitational perturbation, isolate a spinning body completely, and it will still be rotating in 1 trillion years. At the heat death of the universe, in whatever comes after. This is not a tendency or a rule of thumb. It is a precisely exact mathematical law that has held in every experiment, every observation, and every physical interaction that has ever been tested across every scale of physical reality. Here is what makes it truly remarkable. The Austrian mathematician Emmy Noether proved in 1915 that every continuous symmetry of the laws of physics corresponds to a conserved quantity. If the laws of physics are the same today as yesterday, energy is conserved. If they are the same here as 1 meter to the left, linear momentum is conserved. And if they are the same regardless of which direction you orient your experiment, if there is no preferred direction built into the laws of nature, then angular momentum is conserved. Rotational symmetry. No preferred direction, angular momentum conserved. That is the entire chain of reasoning. The conservation law is not a coincidence or an empirical curiosity. It is a mathematical consequence of the fact that the universe has no orientation preference. It treats every direction identically. And that single symmetry, as far as anyone has ever been able to test, holds exactly. Not to good approximation. Exactly. This is why the hierarchy of spinning things looks the way it does. Quantum particles carry spin because relativistic quantum field theory demands it. Atoms inherit angular momentum from their constituent particles. Molecules inherit it from atoms. Protoplanetary disks form because a collapsing gas cloud cannot shed its angular momentum. It can only redistribute it. Planets form within those disks carrying the angular momentum the disk imparted to them. Stars orbit galactic centers because the galaxy formed from a rotating gas cloud whose angular momentum had nowhere else to go. Angular momentum is not generated at each level. It is inherited from the level below, all the way down to whatever the universe's initial conditions were. Conservation of angular momentum is a cosmic memory system. Every spinning thing you can see is carrying a historical record of motion that stretches back without interruption to conditions that existed before the object itself existed. How rotation builds everything. Think about what happens when a cloud of gas collapses under gravity. Your intuition might say, sphere. Gravity is isotropic. It pulls equally toward the center from every direction. A collapsing cloud should produce a sphere. And that intuition is partly correct. But it misses something crucial. The cloud, before it collapses, is not at rest. It has slight irregular motions, turbulent velocity variations caused by the shock waves of nearby supernovae, gravitational nudges from neighboring clouds, the general messiness of fluid dynamics at astronomical scales. Those variations carry a net angular momentum. The cloud, as a whole, has a slight overall spin. Not much, barely measurable, but some. As the cloud contracts under gravity, that slight spin is amplified dramatically. Here is the physics. A rotating object that contracts must rotate faster to conserve its angular momentum. The same principle that makes an ice skater spin faster when she pulls her arms inward. As the cloud's radius shrinks, the rotation rate increases in proportion to the square of the ratio of the radii. The rotation that was imperceptible in the diffuse cloud becomes the dominant organizing force in the collapsing system. This is where the physics does something genuinely beautiful. Material falling inward along the rotation axis can fall all the way to the center, because it has no angular momentum perpendicular to the axis to deflect it. But material falling in from the sides cannot. It carries angular momentum that prevents it from simply spiraling into the center. Instead, it settles into a rotating disk, a flat structure perpendicular to the rotation axis, orbiting the central object at whatever radius allows its angular momentum to balance gravity. The disk is not an accident. It is the mathematically inevitable outcome of angular momentum conservation acting on any collapsing system that has any rotation at all. And in the real, turbulent, gravitationally interactive universe, perfectly non-rotating collapse is extraordinarily unlikely. Any real cloud of gas will have some net angular momentum, so collapse will almost always produce a disk. This is why the rings of Saturn are flat, why the solar system is flat, why galaxies are flat disks, why accretion disks around neutron stars and black holes are flat. Every disk structure in the observable universe is a record of a rotation that pre-existed the disk. The disk is what angular momentum looks like when gravity tries to compress it and cannot. And the cascade goes further. The protoplanetary disk that formed our solar system produced planets that orbit the Sun in roughly the same plane, in roughly the same direction, because they all inherited their angular momentum from the same rotating disk. The Earth's spin today is a direct echo of a velocity gradient in a gas cloud that existed billions of years before any planet formed. The spin was there first. The planet formed around the spin. The galaxy clock and the dark matter problem. The Milky Way is rotating. This is not a small or casual fact. The Milky Way takes approximately 225 to 250 million years to complete one full rotation at the radius of the Sun. That unit, one galactic year, is so large that the entire recorded history of human civilization is less than 100,000th of one. The solar system has completed roughly 20 galactic orbits since it formed. For most of the universe's history, the galaxy has been slowly turning, sweeping its spiral arms through space, building structure, redistributing matter. But galactic rotation turns out to be deeply puzzling in a way that Newtonian physics cannot explain. When a solid disk rotates, a wheel, a plate, a spinning top, every part of it completes one revolution in the same time. The outer edge and the inner center rotate together as a rigid body. But a galaxy is not a solid disk. It is a collection of hundreds of billions of individual stars, each following its own gravitational orbit around the galactic center. And if all that mattered were the gravity of the visible stars and gas, the outer stars should move more slowly than the inner ones. Exactly as the outer planets of the solar system move more slowly than the inner ones, because they feel weaker gravity from the concentrated mass at the center. In the 1960s and 1970s, the American astronomer Vera Rubin measured the rotation speeds of stars at different distances from the centers of galaxies. She expected to find precisely this pattern: fast rotation near the center, falling off steadily toward the edges. Instead, she found something that the physics simply would not allow. The rotation curves were flat. Stars at the extreme outer edges of galaxies were moving just as fast as stars closer to the center. In some cases, marginally faster. This was not a rounding error or an instrumental artifact. It was a systematic result across dozens of galaxies, replicated by other astronomers, using multiple independent methods. The implication was severe. If the outer stars are moving that fast, they are moving too fast to be gravitationally bound by the visible mass. They should have long since flung themselves off into intergalactic space. And yet they were not going anywhere. Something was providing additional gravitational mass, distributed across the outer regions and halos of galaxies, far beyond where the visible stars thinned out. And we could not see it. We still cannot. Dark matter, the name for whatever is providing that additional gravitational scaffolding, has not been directly detected despite decades of searching. Underground detectors shielded by kilometers of rock from cosmic ray background, designed to catch the faint collision signature of a hypothetical, weakly interacting massive particle, have been running for decades without a confirmed signal. Candidate particles have been proposed, argued over, and either excluded by experiment or pushed to increasingly narrow ranges of parameter space. As of now, dark matter remains a gravitational fact with no confirmed physical identity. Vera Rubin used rotation as a diagnostic tool and found something missing. The galaxy's spin was a fingerprint of invisible mass. Every spiral arm winding through the night sky carries, embedded in its rotation curve, evidence of a substance that makes up roughly 27% of the universe's total energy content and has never been directly seen. The rotation is legible. What it is telling us is only partially understood. The Stern-Gerlach shock. In 1922, two German physicists, Otto Stern and Walter Gerlach, performed an experiment that should have, if you grasped what they were expecting versus what they found, made you immediately question everything you thought you knew about the structure of matter. The setup was not complicated. They took silver atoms, vaporized from a heated sample, and passed them through a region of strongly non-uniform magnetic field. Silver atoms have a magnetic moment. They behave like tiny bar magnets. A classical bar magnet in a non-uniform field gets pushed or pulled depending on its orientation. A large collection of atoms with randomly distributed orientations should produce a continuous smear of deflections on the detector. Some pushed strongly one way, some the other, everything in between forming a smooth band. What Stern and Gerlach found was two dots, not a band, not a smear. Two discrete, well-separated spots on the detector plate. Half the atoms deflected one way, the other half deflected the other way, nothing in between. An empty gap on the detector where the intermediate deflections would have landed if intermediate orientations existed. That gap was proof that intermediate orientations did not exist. The angular momentum of the outer electron in silver was not continuous. It was quantized, restricted to exactly two possible values, nothing else. This was a direct experimental proof you could see with your own eyes. Two spots, two choices, nothing in between. The slightly embarrassing historical footnote is that the experiment worked for reasons not fully understood at the time. Stern and Gerlach believed they were measuring the orbital angular momentum of the electron. But orbital angular momentum quantum numbers produce an odd number of possible orientations. Never exactly two. Two orientations implied a quantum number of 1/2, and orbital angular momentum could not produce a half-integer value. 3 years later, Samuel Goudsmit and George Uhlenbeck proposed the explanation. The electron had an intrinsic angular momentum of its own, a spin of 1/2 in units of the reduced Planck constant, entirely separate from any orbital motion. That spin had exactly two possible orientations when measured, up or down, no in between. The Stern-Gerlach experiment had been measuring this intrinsic spin all along, without knowing it was there. Two spots on a detector plate. That was the moment physics discovered that rotation, at its most fundamental level, is not a continuous quantity that can take any value. It is quantized. It comes in specific discrete packets. And the packet size that describes matter, half-integer spin, has consequences that cascade through every level of physical reality above it. The impossible electron. When Goudsmit and Uhlenbeck proposed that the electron had intrinsic spin, they immediately tried to model what this meant physically. The obvious picture was a small charged sphere rotating on its axis, generating a magnetic moment through its spin, the way a current loop generates a magnetic field. They did the calculation. The surface of such a sphere, to produce the measured magnetic moment, would need to be moving at a speed many hundreds of times greater than the speed of light, not marginally exceeding it, not ambiguously close. many hundreds of times greater. They tried to withdraw the paper. Their supervisor, Paul Ehrenfest, had already submitted it. He told them, reportedly, that they were young enough to afford a wrong idea. The idea was not wrong, the model was. The electron is not a small spinning sphere. Modern physics treats it as a point particle, an entity with no known spatial extent, no surface, no radius. You cannot meaningfully define the rotation of something that occupies no space. And yet the electron has angular momentum of exactly 1/2. Always, in every interaction, in every environment, regardless of how fast it is moving or what experiment you use to probe it. The resolution came from Paul Dirac in 1928. Dirac was trying to write a quantum mechanical equation for the electron that was consistent with special relativity. The Schrödinger equation handled electrons well at low velocities but broke down at relativistic speeds. When Dirac imposed the requirement that his equation be Lorentz invariant, that it obey the symmetries of special relativity, the mathematics produced a 4-component wave function without him asking for one. 2 components described an electron with spin up and spin down. The other 2 described a particle with identical mass but opposite charge. That second particle, the positron, was experimentally discovered 4 years later. Carl Anderson won the Nobel Prize for it. Dirac had predicted antimatter as a mathematical byproduct of taking spins seriously at the relativistic level. What the Dirac equation established is this. Spin is not an optional feature of the electron. It is not something that could have been left out. It is a necessary consequence of combining quantum mechanics with special relativity. Any point particle described by a relativistic quantum theory must have spin. The spin 1/2 of the electron falls out of the mathematics, whether you want it to or not. It is as inevitable as the existence of antimatter, which is to say, completely inevitable and confirmed by experiment. Spin at the most fundamental level is not a behavior of matter. It is part of the definition of matter itself. Why matter occupies space at all? Here is a thought experiment that sounds absurd, but is completely serious. Imagine removing spin from the universe. Not slowing things down, not reducing angular momentum. Removing the intrinsic quantum spin of fundamental particles. Setting it to 0 for everything. What happens? Matter as we know it ceases to exist. Not in some metaphorical sense. Literally, physically, immediately. The reason is the Pauli exclusion principle. Formulated by Wolfgang Pauli in 1925, it states that no 2 identical fermions, no 2 particles with half-integer spin can occupy the same quantum state simultaneously. Same position, same energy, same spin orientation. Forbidden. 2 electrons can share the same atomic orbital only if they have opposite spins, because then they are not in identical quantum states. The moment they would need to match, the Pauli exclusion principle prevents it. This rule has consequences that cascade through all of chemistry. The electrons around a nucleus cannot all pile into the lowest energy level. The first orbital holds 2 electrons with opposite spins. Then it is full. The next electron must go to the second level. The third and fourth fill spots in the second shell. Eventually that shell fills and electrons must occupy the third, and so on outward. Every additional electron occupies a higher energy level with a different spatial distribution and different chemical character. This shell structure is exactly what produces the periodic table. the patterns of chemical reactivity, the valence electrons at the outermost shells, the way atoms combine and share electrons to fill their outer levels. All of it is determined by the shell structure, which is determined by the exclusion principle, which is determined by the half-integer spin of electrons. Without spin, all electrons would collapse into the lowest energy level. Every element would have the same electronic structure. Chemistry would not exist as a subject. There would be no periodic table, no molecular bonds, no organic chemistry, no biochemistry, no life. And the exclusion principle explains something even more immediate. It explains why your hand does not pass through the table. Atoms are almost entirely empty space. The nucleus is roughly 100,000 times smaller than the atom. The reason solid matter feels solid is not that nuclei are touching. It is that when two atoms are pushed close enough together, their electron clouds begin to overlap. The electrons from different atoms would need to occupy the same spatial region. The Pauli exclusion principle generates an effective repulsive force. Not electromagnetic, not gravitational, but purely quantum mechanical, that resists this overlap. The floor holds your weight because half-integer spin statistics prevent electron clouds from interpenetrating. In extreme astrophysical conditions, this principle becomes the difference between existence and annihilation. When a star runs out of nuclear fuel and its core collapses under its own weight, the collapse in a white dwarf is halted by electron degeneracy pressure, the quantum mechanical resistance of electrons to being forced into the same states. In a neutron star, the collapse is halted by neutron degeneracy pressure, the same principle applied to neutrons, which are also spin 1/2 particles. Dead stars are held up by quantum spin. Remove spin from the universe and matter has no shell structure, no chemistry, no solidity, and no resistance to gravitational collapse. Every white dwarf and neutron star in the galaxy becomes a black hole. Every floor stops holding any weight. Every atom loses its chemical identity. Spin is not a peripheral feature of physical reality. It is the load-bearing element of physical reality. It is what stops everything from falling through everything else. Spin as the organizing principle of all matter. There is a theorem in quantum field theory called the spin statistics theorem. Richard Feynman, one of the most gifted physics explainers of the 20th century, said explicitly that he could not give an elementary explanation of it. He tried multiple times. He could not find a way to make it feel intuitive or obviously motivated from simple principles. All he could say was that the derivation worked. The result was correct, and the correct result divided every particle in the universe into exactly two categories. Particles with half-integer spin, electrons, quarks, neutrinos, protons, neutrons are fermions. They obey Fermi-Dirac statistics and the Pauli exclusion principle. No two of them can share the same quantum state. Particles with integer spin, photons, gluons, W and Z bosons, the Higgs boson, are bosons. They obey Bose-Einstein statistics and have no exclusion principle. In fact, they prefer to pile into the same state. Lasers work because photons are bosons that can coherently occupy identical states in enormous numbers. There is no third category. There is no continuous gradation between the two. Every particle in the universe is one or the other, determined entirely by its spin value. Spin determines statistics. Statistics determines collective behavior. collective behavior determines the entire structure of matter and radiation in the observable universe. Why does spin determine statistics? The formal proof requires two things: Lorentz invariance, the requirement that physics looks the same in all inertial reference frames, and the condition that quantum fields at space-like separations commute or anti-commute to preserve causality. Fields describing half-integer spin particles must anti-commute. That anti-commutation relation is exactly what produces the exclusion principle. The mathematics locks it in. There is no other option consistent with special relativity and causality simultaneously. What this means is that spin is not just a property particles happen to carry around. Spin is a constraint that space-time itself imposes on quantum fields. The requirement that physics obey the symmetries of special relativity forces quantum fields to carry specific spin values, and those spin values force the entire statistical structure of matter. The fermion-boson division, the division that separates the material fabric of the universe from the forces that act upon it, is written in the symmetry requirements of space-time. Spin is the signature of Lorentz symmetry at the level of individual particles. Consider the force-carrying particles. The photon, which mediates electromagnetism, has spin 1. The gluons, which carry the strong nuclear force, have spin 1. The W and Z bosons, which carry the weak force, have spin 1. The graviton, if it exists as a quantized particle, would have spin 2. The Higgs boson, which gives mass to other particles, has spin 0. Every force-carrying particle in the Standard Model is a boson. Every matter particle is a fermion. The spin of the force carrier determines the mathematical structure of the force it mediates, the angular dependence of its interactions, the number of polarization states it can sustain, the way it couples to matter. Spin is the organizational principle of the Standard Model. Take it away, and the Standard Model does not produce a simpler universe. It produces no universe at all. The 0 at the bottom of the ledger. Now we need to talk about the number, the one we started with, the one that should genuinely bother you. Add up all the angular momentum in the observable universe, every galaxy spinning in its particular direction, every star orbiting within those galaxies, every planet orbiting its star, every moon, every accretion disk blazing around every neutron star and black hole, every spin carried by every fermion in every atom in every cubic meter of space. Do the full vector accounting, treating every angular momentum as an arrow pointing in a direction, adding all the arrows together, tip to tail. The sum, to within current measurement precision, is 0. Not small, not negligible in the way that a large number divided by an even larger volume becomes small. 0 in the sense that the universe's angular momenta appear to cancel each other with a precision that no measurement has yet been able to detect any residual from. Galaxies spin in both directions in roughly equal numbers. The cosmic microwave background, the oldest light in the universe, the thermal afterglow of the Big Bang filling the sky from every direction, shows no preferred rotation axis, no asymmetry that would signal a global spin. The large-scale structure of the observable universe is isotropic in this respect to extraordinary precision. The European Space Agency's Planck satellite placed an upper limit on the universe's global rotation of roughly 10 to the -9 radians per Hubble time. If the universe is rotating at all, It has completed at most 1/1000th of a radian of rotation over its entire 13.8 billion year history. That is not slow. That is, for all practical purposes, stationary. 2 trillion galaxies, each one spinning, each one containing hundreds of billions of rotating stars, each star built from atoms whose electrons carry intrinsic spin that has never changed since those electrons were created. And the whole thing cancels. There is no known law of physics that requires this. There is no symmetry principle that obviously demands zero net angular momentum for the universe as a whole. There is no mechanism that could have actively enforced the cancellation. The standard explanation that galaxies acquired their angular momenta through tidal gravitational interactions with their neighbors during structure formation, and that these interactions automatically conserve total angular momentum, so equal and opposite spins are produced across the whole, is correct as far as it goes. But it does not explain why the initial conditions of the universe were set up to produce a ledger that balances to 0 rather than to some other number. The ledger is balanced. Nobody has found the first deposit slip. The rotating universe. Nightmare. On the 28th of April, 1949, Kurt Gödel presented a paper at a Princeton conference celebrating Albert Einstein's 70th birthday. Gödel was already famous. His incompleteness theorems of 1931 had proved that any sufficiently powerful formal mathematical system must contain true statements that cannot be proved within that system, demolishing, in 2 concise pages, the entire program of finding a complete and consistent foundation for mathematics. He had destroyed a dream that had occupied the greatest mathematical minds of the early 20th century. Now, at Einstein's birthday conference, he had found an exact solution to Einstein's field equations of general relativity. The solution described a rotating universe. In this universe, matter was distributed uniformly throughout space, as in standard cosmological models. But the matter was rotating. And in this rotating universe, Gödel showed a sufficiently motivated traveler could follow a specific path through space, accelerating, curving, returning, and arrive back not merely at the same location, but at the same moment in time from which they had departed. A closed, time-like curve. A path through space-time that loops back on itself in time. What Gödel had found was that a rotating universe contains paths through space-time that allow travel into the past. Not as a science fiction conceit, as a mathematically exact consequence of Einstein's field equations applied to a universe with net angular momentum. The rotation of the universe twists the light cones, the geometric structures that define which events can causally influence which other events. In a non-rotating universe, those cones are clean. Your past is what came before you. Your future is what comes after. The distinction is absolute and universal. In a rotating universe, the cones tilt, and if they tilt enough, a path forward through time can curve around and arrive at its own starting point. This is deeply, uncomfortably problematic. Closed time-like curves permit causal paradoxes of the kind that make physicists visibly uncomfortable at conferences. They violate what Stephen Hawking called the chronological protection conjecture, the hypothesis that the laws of physics must conspire to prevent their formation in any physically realizable scenario. Hawking believed this had to be true because the alternative was a universe in which the arrow of time the one-way flow from past to future that underlies thermodynamics, memory, causality, and the entire structure of how events are related to each other, could be locally reversed. Our universe does not appear to be the Gödel universe. Global rotation is not observed. Closed time-like curves are not observed. Cosmological measurements are consistent with a non-rotating expanding universe to extraordinary precision. But here is what Gödel's solution tells us about the zero. The near-zero net angular momentum of our universe is not just an interesting cosmological statistic. It may be a necessary feature of a universe where time works cleanly, where the past is irrevocably past, where causes reliably precede their effects, where entropy increases in one direction and not the other, where the arrow of time exists at all. A universe with significant net rotation would be one where the causal structure of space-time is compromised, where it becomes geometrically possible to return to your own past. Whether that makes complex chemistry impossible, whether it makes biology impossible, whether it makes the kind of stable thermodynamic gradients that life exploits impossible. These questions do not have settled answers, but they are serious questions. Perhaps the zero is a coincidence. Perhaps it is a statistical consequence of how angular momentum was distributed during structure formation. Or perhaps it is something more fundamental, a necessary condition for the universe to be the kind of place where time flows consistently enough for anything complicated to happen. The zero is doing a great deal of work, and nobody is entirely sure what all of it is. Space built from spin. There is one more idea that deserves space here, even though it is speculative, even though it is not confirmed, and even though the experiments that could test it lie decades or centuries in the future. It is the possibility that we have been asking the relationship between space and spin backwards all along. Throughout this entire story, the implicit frame has been this: space is the stage, and spin is what particles do on it. The universe provides a three-dimensional geometry, and within that geometry, things rotate, orbit, precess, and carry angular momentum. The stage is prior. The dancing is subsequent. But what if the stage is built from the dancing? What if space-time is not the container in which quantum spin occurs, but is itself an emergent structure arising from quantum spin at the most fundamental level? This is the central proposition of loop quantum gravity, a serious, mathematically rigorous, actively developed program in theoretical physics pursued by Carlo Rovelli, Lee Smolin, and many others over the past 4 decades. Loop quantum gravity attempts to apply the principles of quantum mechanics directly to the geometry of space-time itself, to quantize space and time the way quantum mechanics quantizes energy and matter. The result is a picture in which space, at the Planck scale, roughly 10 to the minus 35 meters, is not a smooth, continuous medium. It is a discrete network. Specifically, it is a spin network, a mathematical graph in which each edge carries a label, and that label is a value of quantum spin, not the spin of any particle. Just spin as a pure mathematical quantity assigned to the connections between nodes in a network. And those spin values are not decorative. They are the geometric properties of the space the network represents. The area of any surface in the network is determined by the spins on the edges that cross it. The volume of any region is determined by the spins at the nodes within it. Area and volume are quantized. They come in discrete minimum units set by the Planck scale, below which the concept of spatial extent simply does not apply. Space, in loop quantum gravity, is organized quantum angular momentum. The three-dimensional geometry you perceive as the room around you, the distances, the volumes, the angles, is an emergent macroscopic averaging over an enormous number of discrete quantized spin values operating at the Planck scale. The apparent smooth geometry of space is what quantum spin looks like from far enough away. A related idea, developed by Roger Penrose starting in the 1960s and called twistor theory, arrives at something similar from a different direction. In twistor space, the fundamental objects are not events at locations in space-time, but extended entities, twistors, that encode momentum, energy, and angular momentum as a single unified geometric object. Points in ordinary space-time are not primary in twistor theory. They are derived, secondary structures that emerge from the intersection of twistors. The spinning directed structure is primary. The space-time event is the projection. Twistor theory spent decades as a beautiful mathematical framework with limited physical application. Then in 2003, Edward Witten showed that the amplitudes describing particle interactions could be reformulated in twistor space with extraordinary elegance. Calculations that required thousands of Feynman diagrams in the traditional approach collapsed to compact, transparent expressions in the twistor language. The mathematics built around spin as the foundational object turned out to be the most efficient language for describing how particles interact that physicists have yet discovered. Both loop quantum gravity and twistor theory, arriving from different starting points by different mathematical routes, suggest the same provocative inversion. Spin is not what happens inside space-time. Space-time is what spin looks like from far enough away. If either of these pictures is correct, and we cannot yet confirm or rule out either, then the question that opened this documentary dissolves into something deeper. We asked, why does everything in the universe spin? We expected an answer about mechanisms and initial conditions. But if space is built from spin network, the question changes entirely. Everything spins not because spinning objects were placed into a universe and happen to rotate. Everything spins because rotation, at the most fundamental level, is what the universe is made of. Asking why things have angular momentum is like asking why matter occupies space. It does not occur inside space. It is the ingredient from which space is constructed. What we do not know, the honest account of rotation in the universe, has open questions at every level, and they deserve acknowledgement without apology. We do not know why the universe began with the angular momentum it began with. Conservation laws explain how angular momentum is preserved and redistributed from any initial state. They do not explain what determined the initial state. This is not a technical gap awaiting a more careful calculation. It is a conceptual boundary at the edge of what physical theories, as currently formulated, are structured to address. Laws of physics describe the evolution of systems from initial conditions. The initial conditions themselves are, in a deep sense, prior to the laws. We do not know whether the net global angular momentum of the universe is exactly zero or merely very close to zero. The observational upper bound is extraordinarily tight. The Planck satellite's constraints represent one of the most precise cosmological measurements ever made, but a tiny residual global rotation below current detection thresholds cannot be ruled out. The difference between exactly zero and almost zero matters enormously, given what Gödel's rotating universe solution implies about causality and the arrow of time. We do not know the identity of dark matter. Vera Rubin's flat rotation curves are among the most robust observational results in astrophysics. The gravitational scaffolding that produces them is real. But what it is physically, what particle or particles constitute it, why they have the properties they do, why they interact with ordinary matter only through gravity, remains entirely unknown after decades of serious experimental effort. We do not know whether loop quantum gravity or twistor theory are correct descriptions of reality at the Planck scale. Both are mathematically rigorous and physically motivated. Neither has made a confirmed prediction that distinguishes it from competing theories at any scale currently accessible to experiment. The Planck scale is 16 orders of magnitude smaller than the smallest structures that particle accelerators currently probe. And we do not know whether the connection between global rotation, the arrow of time, and the possibility of complex life is coincidence or necessity. Gödel's theorem establishes that rotation could break causality in principle. Whether a slightly rotating universe would actually produce the pathological causal structures that would foreclose chemistry and biology is a question that sits at the intersection of general relativity, thermodynamics, and the philosophy of physics, and it does not currently have a settled answer. The books balance. The zero holds. Nobody has explained either one to the satisfaction of everyone who has thought carefully about them. The stillness that is not still. Go back to the room. Feel the floor beneath you, the air around you. The stillness that your nervous system is reporting with complete conviction. You know now what that stillness actually is. You're being carried eastward at hundreds of kilometers per hour on the surface of a rotating planet. That planet is tracing a vast ellipse around the Sun at 30 kilometers per second. The Sun is sweeping through the Milky Way at 230 kilometers per second. The Milky Way is itself rotating, turning its spiral arms through a darkness that has been accumulating since the universe was young. Every atom in your body is broadcasting quantum spin at 1.42 gigahertz into the void, announcing the intrinsic angular momentum of hydrogen to anyone with a radio telescope and the patience to listen. And underneath all of that, underneath every scale of rotation, every orbit, every spin, is the law that holds it all together. Angular momentum is conserved, not as a tendency, not as an approximation, as an exact mathematical consequence of the fact that the universe has no preferred direction. The same spin that was present in the quantum fields of the early universe, encoded in conditions that preceded every star and planet and galaxy and observer, has been redistributed and reshuffled and passed from scale to scale without a single unit of it being created or destroyed across the entire history of the cosmos. And the total, after all that redistribution, balances to zero. 2 trillion galaxies, every one of them spinning. The vector sum, nothing. That zero is either the most elaborate statistical cancellation in the history of physics, or it is the reason time flows in one direction. The reason your memories are of the past and not the future. The reason broken glasses do not unshatter and cold tea does not spontaneously reheat. The reason cause precedes effect, entropy increases, and the universe is navigable by anything complex enough to navigate it. Rotation is not something the universe does. It is, at every scale from the quantum to the cosmic, something the universe is. The spin of an electron in your body right now is angular momentum that has been conserved since before the Earth existed. The spiral arms of the Milky Way are a record of a rotation that was seeded before the galaxy formed. Every disk, every orbit, every ring, every spiral. These are not decorative features of the universe. They are the universe writing its conservation laws in starlight and stone. The stillness you feel is a local illusion built from a reference frame inside a rotating system. The universe underneath that illusion is turning. It always has been. It does not appear to know how to stop. You've been watching the entire history of the universe. Don't forget to like and subscribe and leave a comment. Tell us what you think. Thanks for watching, and we'll see you next time.